On to tonight's topic. You may have noticed on the program that the speakers on this evening's roster come from all different organizations. We have the City of Newport, we have the Newport Tree Conservancy, we have the Preservation Society, we have Aquidneck Land Trust, Bartlett Tree Experts. Have I forgotten anyone? I don't think so. But anyway, we all come at this topic of the health of our city arboretum from different angles, but we all share the concern that Newport's beech trees and its whole arboretum are both environmentally and culturally important. And I think the fact that we can all come together and have this event is a great thing. And the fact that we get such a great response when we do this with hundreds of registrations is proof that Newporters really do care about this topic. So we have a lot to cover. I think we have the best possible opening speaker, and that is Scott Wheeler, Superintendent of Parks, Grounds, and Forestry for the City of Newport. So please welcome Scott Wheeler. I didn't advance my slides at all. So you can just go through.
All right. Thank you, Jim. And thank you so much for hosting this event. As I'll talk a little bit, Preservation Society really has been a leader for over 3 decades when it comes to tree management, and we're trying to emulate that with the city. As the title of this slide shows, I've been doing this for a little while. But when we think of Newport's trees, we really, it's almost an idyllic vision. These are a line of elms along Memorial Boulevard, wonderful boulevard recommended by Olmsted, and our beaches. We're going to have some incredible speakers later that are going to talk about the potential to save a beech tree. We can actually save beech trees now, which is we had no idea we'd be there 3 years ago. And we have some other amazing diverse trees. This is river birch that was on Olmsted's plan for Morton Park. And this is really what I thought I was walking into when I came to Newport, but I was wrong. Lily Dick, who's here, founder of the Newport Tree Conservancy, they had done their homework. And dating back to 1992, we had an inventory that sort of just laid out how bleak things were. Only about half of our locations in the city available for trees were planted. Of those, 14% needed to be removed. They were literally hazards. Of that 51%, 31% were Norway maples, which for plant nerds, that's really, really scary. Beyond that, the city of Newport and its enlightened management used to go up and down every street and top all the trees, which was just horrendous. Norway maples are, not only are they just a weak tree, they have this knack that if they're transplanted, their roots start growing around in a circle and they don't stop. Really just time bombs. So I've spent a lot of time taking down trees. And, a lot of talks about beech trees. We have lost a lot of beech trees. This one fell on the King House during a Patriots playoff game. So really what it came down to when I looked at what my mission has been for the past 31 years, it is really simple. Plant. Plant, plant, and plant more. Because there's nothing that my job was to create a community forest that lived up to what people thought we had. And we're very lucky to have had long-term partners like the Tree Conservancy that did this. I was putting this slide together, and it just happened to be the gentleman on the left, Joe Baldea, 30-plus year employee, had just happened to pass away so I thought it was fitting to include him. The person in the right is our foreman, Charles Riddoff, who does a fantastic job. But how are we going to plant trees? So we got state changes to state enabling legislation that allowed us to plant up to 20 feet onto private property because we know Newport's colonial streets aren't where trees belong. We introduced bare root tree planting, one of the first communities. Sam Kinder gave us that tip. We had launched commemorative tree planting. partners with Eastern Utilities, and we had a lot of success. Now each year I meet with the Newport Tree Conservancy to figure out where we can offer commemorative memorial trees. And we're at the point where we have a hard time. There's parks that people desperately want to plant a tree in, and we're just not going to plant anymore. And our parkways and parks, but that can give you the impression that we're actually in a good place. But we're not, because as much progress as we made in our parks and our parkways, when we look at our community as a whole, we're staying steady or falling behind. We just completed, through a grant, through DEM, working with the Green Infrastructure Center, an in-depth look at our canopy analysis, the amount of impervious surface we have in the city. And I just encourage you, it looks a little small on this, but if you really look at it, this tells a few stories. One is we have very few forests left in Newport. Lots of communities have private properties with forests. There's really just 5 or 6 in Newport. You know, we've got Maintonoi Park, the Malbone Estate, the wetlands around the Rogers High School and Ballard, a little bit down towards Brenton State Park, but that's it. And when you look at our neighborhoods, you'll just see we have a huge percentage of where we do have permeable surface, we have lawns and more lawns. And lawns are wonderful, but they provide almost no ecological benefit compared to meadows and forests. These dark areas goes by shading, just shows you how much impervious surface we have. And then on top of that, you can see, well, that results in heat. And we all know that our summers are getting hotter and hotter and hotter. And this is the one that really, and hopefully I'll read out just some of these numbers, because this is really what it takes away. Central Falls has 58% of the land cover in Central Falls is impermeable surface, but they still have 18% tree cover. The city of East Providence has 37% impermeable surface, and they already have 34% cover. In Newport, our impermeable surface is 36%, but we only have 19% tree cover. And that just is not where we want to be. We have a huge stormwater problem in Newport. We're really very important ecologically for migrating birds. So, you know, what is the solutions? What we need to do is we need to get out into the neighborhoods. People have gotten afraid of trees. Insurance companies have made them afraid of big trees. So where we do plant trees, too often it's short-lived, small flowering trees that don't live as long, that provide less benefit. We need to work with our large property owners to convince them lawns are great, but you know, meadows can be beautiful too. Small woodland forests can be, you know, a way to really add more interest to your property. So what I really hope that we'll take from this is when we talk today about speech, this isn't the time to sort of be pessimistic. Really, this is the opportunity for us as a community to really show some initiative, to move forward, to recognize we've done some great things, but we really need to do more than ever to restore community forests for our stormwater, for quality of life. But we're very lucky in that pursuit to have lots of partners. And our partner that has really been there for, well, prior to my 33, 34 years ago, Lily, is the Newport Tree Conservancy. So I am really just pleased to be able to introduce Natasha Harrison for the Newport Tree Conservancy, and who's really leading the effort to begin for us to start making a dent in those numbers. Natasha?
Thank you, Scott. We have to give one more round of applause to Scott because he has been leading the charge here in Newport, and without Scott's knowledge and effort, the Newport Tree Conservancy couldn't do our work, so thank you. Can you see? Oh, there it is. So the Newport Tree Conservancy, we started back in 1987, as Scott mentioned a long time ago. Lily Dick here gathered a bunch of friends who were concerned about trees in Newport and the survival rate and how we were approaching our tree planting. And the organization has just grown. And as Scott mentioned, the most important thing that we do is we partner with the city of Newport. This green button, right? Did it move? Okay, there's the city of Newport. So we work together. We work together to identify the areas that can be planted, the species that are going to be planted. It really is a team effort. And one of the most important things that we're doing right now is trying to figure out where we have available planting. A lot of our area that is available is private. So there's just so much that we can do in our parks and parkways, like Scott said, but we also have private property that we need to engage with. And that's where the Tree Conservancy comes in, literally door to door, talking to people about their property, what species of tree they could have, trying to dispel the myth of trees not being, what is going on? How did you do it and I can't? Oh, there. So this is our Trees for Residents. We have two programs, one in the spring and one in the fall. Here is Janet and Charlie, our city arborists. They're partnering with Joe and Morgan, who are horticulturists at the Tree Conservancy, to find locations. The Tree Conservancy fundraises for every tree put in the ground in public space in Newport. The city of Newport does not have a line item in their budget, so that's our responsibility. And also deciding what we're going to plant and procuring it and getting it delivered, which is not an easy feat. So we're very lucky to have some pros who know where to find the right trees. One of the ways that we've been addressing that issue that you saw on Scott's slide is the heat and the areas where we have less trees, is working with this idea of tree equity and a tree equity score. So Rhode Island was one of the first states to use this system to understand where we can plant trees to be providing the benefits to everyone in our community and offsetting those hot areas and providing the shade that's needed. So I am proud to say, since we started in 2020, we had a tree equity score of 77, and it's gone up to 86 in the past 5 or 6 years. So we're getting there. We still don't have the tree cover that I think we want, but we're getting the residents to understand the importance and engage with us around the importance of trees. If they plant a tree, and they don't want the leaves, and that's their reason, then we're there to explain that it's so much more. There's so much more to planting a tree, not only for you and your property, but for the community, because we're really all here trying to accomplish the same thing. Once the trees are planted with the city, we go back and we water every single newly planted tree, our staff and our volunteers. This year, with the help of the DEM, we're doing the first year trees, this year's trees, but we're also going to be watering the trees that went in last year, which is the first time we've had enough capacity, because we're a tiny organization, to be able to do that. And then we have our tree corps, who are the volunteers who do the tree care during the weekend. Now it's going crazy, you guys. There, oh. So speaking of forests, Myantonomie Park is, if you're not familiar with Myantonomie Park, it's a big park up in the north end where there's a low tree equity score, and the Newport Tree Conservancy with the city and 80 volunteers per year have planted 100 trees in that forest every year, native trees. So it's a really big effort. We work with the city. Luckily, they dig the holes. Jenna digs the holes, because that's the hardest part. But it's a really good community building effort, and we're able to sort of gain some momentum in the neighborhood and start to be familiar with the residents. And then when we go to their house and knock on their door, maybe they remember us a little bit, because we've been in the park for so many years, planting so many trees. So if you ever want to go help us, we do it at the last weekend of October usually. And then our kids. So for us, we can do all of this work in a vacuum, but if we don't get the next generation inspired and understanding the benefit of trees, then we're not doing our job as a community organization. So we're really working to not only educate them about trees, but connect them with trees, because they have to get like that feeling inside that we have. And we need them to be the next stewards, like all of us. They're going to be the next us, and they need to understand how important that is. So these are some kids this is Myantonomie. We bring a lot of kids to Myantonomie because it's it feels like the wilderness for them, which is great, because it is kind of the wilderness. Sorry, it's probably going to jump ahead. And then we also do community programs. We do free tree walks every month. Joe Verstandig, our lead horticulturist, is very popular. People love to come on his walks because there's so much to learn about in every neighborhood. So we want our residents to understand and connect with the trees in their neighborhoods and their parks. So we get that funded and it's free. And then he does a lot of demonstrations. We have workshops, and we have, I just tap it on its own. And then we have our facility, our tree growing facility, which is our Heritage Tree House, which is on the property behind Rogers High School. And as you know, Rogers High School is being renovated, so we're going to be moving. But the most important thing that we're doing at the Heritage Tree House is historic preservation through horticulture. We're propagating the most iconic trees in Newport through different methods, grafting and seed starting and soft cuttings, and growing them out. So when the parent tree dies, we have the identical DNA replacement for that tree. So that preserves the historic landscapes that we have in Newport. So many of our properties that we are familiar with have the tree that is the icon that is in sort of relationship to the building. So we're trying to keep that DNA alive, keep that diversity in Newport, and grow them out and then get them out into the community so we can have that, continue that amazing diversity that we have with these special trees. We're also doing a lot of more online and lots of essays and articles so that we can kind of get out the ideas that we have around propagating and the information. People are really hungry for information and want to know, so luckily we have a couple of great writers on our team. So, And the last program I want to talk about is our arboreta program. So we have a number of arboreta that we do the accreditation for. They're private properties that have a significant collection of trees and woody species. The one requirement once you're accredited with the Morton Arboretum is you have to be open to the public 1 day a year. So we're able to do that for private citizens, and we are the ones who can coordinate their public day, find something within their property that really is something that needs to be shared, and people can come to the properties that they would never see otherwise and experience species of trees and different plants that are otherwise unavailable. So it's a great program, and I'm going to let Joe talk a little bit more about that, because he's the person who does the accreditation. It's not an easy feat. So that's the Tree Conservancy. Thank you so much, Joe. Oh, sorry, this is Joe. Joe Verstandig. Yay! I just wanted to say, Joe is our Living Collections Manager. That's his title, so I just wanted to make sure I introduced you correctly.
Perfect. Thank you, Natasha. All right. Can everyone hear me okay? Just want to know where to lean in here. I feel underdressed again, but I'm embracing it. I'm embracing it this time. I feel good. All right. So today, I want to talk to you a little bit about this world-class plant collection that we have in Newport that greets you as you move through our streets and walk down our sidewalks and paths. It really is a special tree collection we have here in Newport. Green button. Okay. So what is an arboretum? So I like to think of an arboretum as a collection of woody plants, curated and inventoried. They each get their own number, and they are tools for study and a tool for education as well. So our arboretum in Newport is a spectacular one. It's a world-class collection, like I said. Whoop, I'm going back, red button. So our arboretum has a wonderful collection of woody plants. You can see there on the left, that's one of Scott's favorite trees. That's the Green Mountain Sugar Maple in Turrow Park in beautiful fall color. And on the right, we have the winter blooming vernal witch hazel in Myantonomy Park. Did I say Myantonomy? I meant Turrow Park. And then the bottom right there, we have the Japanese white pine in Queen Anne Square, one of my favorite evergreens in town. So arboretums come in all different shapes and sizes. And this is a little example, a little look into what our arboretum looks like here in Newport. And like Natasha said, there is many arboreta, the plural of arboretum, in Newport. But the biggest one is, of course, the Newport Arboretum. Now, the Newport Arboretum is represented, it's made up by all the trees and shrubs growing on public property in Newport. And in 2014, the Newport Arboretum became New England's first citywide accredited arboretum and it was accredited through ArbNet, which is the register that is run by the Morton Arboretum in Lisle, Illinois. And that was quite the accomplishment, and we were able to achieve level 2 accreditation status. And there's 4 levels to accreditation, and as you go up each level, it requires bigger collections, more education, more interpretation, more signage, more collaboration. So we were able to achieve level 2, and with level 2 comes this enhanced educational aspect. So it was perfect for the Newport Tree Conservancy to kind of fill that role and take on this education and connecting the public with trees in our public collections. So some years ago, we started doing monthly tree walks, and usually it's the third Thursday of every month, and we go and we walk through a public park or a public location, and we talk about the trees, and you can see on the right there, that's last month. Scott led the walk through Miantonomi Park, and we had a nice turnout, a beautiful day. And we do things like workshops, like Natasha mentioned. We do demonstrations, things on like how to plant a tree, how to do proper pruning, how to irrigate your tree properly, how to diagnose problems that your home landscape might have. And of course, we do lectures and like something like this, where we're talking about our collection in like a presentation or a lecture-like setting. And then, like Natasha mentioned, we started doing propagation work some years ago, and you can see there on the right, that is a whip and tongue graft, and that is a clone of the large pin oak in Miantonomi Park, and we got great take on that, so we have a number of trees that we're planning on planting back in the park, so we're very excited about that. And then we also do interpretation of the collections. We're always asking questions. We want to know who, what, when, where, why, and how. And that tree on the bottom there, that's a Korean whitebeam, Sorbus alnifolia in Morton Park. And when I first got to Newport, it was this beautiful small tree with this wonderful shape, and I witnessed it in flower, beautiful white flowers that smothered the branches. And the next year, I pretty much waited the whole year to see it flower again, and I go out there and no flowers. The tree is completely bare. So I wanted to know why. So I did some research, and I wrote about it. And so you can find these articles on our website. So we're always asking questions. We always want to know more about the plant collection that we have in Newport. And of course, all of this is possible with the Newport Tree Conservancy's partnership with the city of Newport. And we're thankful for that. All right, it went for me. All right, so the Newport Arboretum by the numbers. So in actuality, the Newport Arboretum has tens of thousands of individual trees. Not all of them are inventoried. So to get you a good snapshot of the trees that the public is most familiar with, I compiled all the data from our public parks. And these are our major parks in Newport that have 20 or more trees. So places like Miantonomi Park, Turo Park, Queen Anne Square, Aquidneck Park. And when you compile all those collections up, you get a little bit over 1,200 inventoried plants. And the diversity is great. We have over 170 species and cultivars represented in those collections. And I thought about quizzing the group here on what were the most common trees in our plant collections. And I did so today on our tree walk, and it turns out London plane tree is the runaway most common tree in our parks, probably because it makes a great street tree and a great urban tree. And then Kwanzan cherry, which I'm sure all of you are seeing right now as you drive around Newport, those bright, almost neon pink blooms that smothered the tree this time of year, the latest cherry to bloom. And then pin oak, like the Kwanzan cherry, is a great durable tree, very adaptable, so that rounds out the top 3. And you can see in the picture there our city crew planting a London plane tree with a pin oak in the background at King Park. And then in the bottom left you have the Kwanzan cherry, the half circle there in Morton Park. And if you're not familiar with that planting in Morton Park, it's worth a visit, absolutely. And right now it's in peak bloom. So these trees in the public space in Newport, they're very beneficial to this community. And with Tree Keeper, which is our inventory tool, I was able to compile the benefits that these trees provide over a 5-year period. And there's a lot of benefits that we can't calculate. You know, the hours spent frolicking through our parks and hours napping under the shade of an oak tree. But the benefits that we can calculate, it was pretty remarkable. Over 140,000 pounds of carbon sequestered, almost, 4.5 million gallons of rainfall intercepted, and about 52,000 ounces of ozone removed from our atmosphere. So not only are these trees beautiful to look at, they are also very beneficial to our community. So let's zoom out a sec, and this is a snapshot from our inventory software, TreeKeeper, and all those highlighted sites you see, those are all beech trees, both on public and private property. And 504 beech trees we have inventoried. Now, this is probably just a fraction of what actually exists in Newport, because we can't obviously inventory every tree as much as we'd like to try to do that. But I'd like to draw your attention to this cluster. Let's see if it does it. Come on. There it is. Do we know what that is? Salve Regina University. So that's Salve Regina in our inventory has nearly 200 beech trees, and our inventory was taken a few years ago. So I'm sure that number it's probably more. I think the inventory was done by Salve students. So it's very possible that inventory is an underestimate of what actually exists at Salve Regina University. So it's important to remember that Salve contains potentially the most extensive beech collection in Newport, which is pretty remarkable. So let's talk about the Newport Arboretum's beech collection. So in our inventory, there are 46 individuals, 31 of which are located at Aquidneck Park. So the Aquidneck Park is the heart of our beech collection. And if you add up all the diameters of the trunks, you get a total of 882 inches of diameter, and that averages about 19 inches per tree. So we have trees of all sizes. You can see our largest tree has a DBH of 80 inches, and that is the large European beech tree in King Park next to the Edward King House, and unfortunately that tree is in a great state of decline. But it is remarkable, even to just look at the framework of the tree, so I would recommend visiting it. And that is also the largest tree in the Newport Arboretum. We have both of the common beech species represented. We don't have any Asian species of beech, but we do have Fagus sylvatica, the European beech, and 8 cultivars of European beech, and we also have American beech, Fagus grandifolia. And there on the bottom, I'm going to go back real quick. I forgot to mention one of my favorite beech cultivars, the dwarf purple leaf beech, Purpurea pendula, which is kind of looks like cousin it. It's a dwarf, and it's usually top grafted to give it kind of this interesting kind of like umbrella look to it. It's a great plant, a great dwarf beech cultivar. So some other beech highlights around the Newport Arboretum. One of my favorite trees is the purple leaf beech in Storer Park. It's a wonderful scene. The tree has plenty of space to grow, and it's extremely happy and vigorous, and it's definitely a good tree to go visit during the golden hour, and it's got this beautiful backdrop with the harbor and the bridge and Goat Island. It's a magnificent specimen. And then one of my favorites, one of the first trees I ever learned when I was an intern was the purple fountain beech, and that's a narrow weeping cultivar with purple leaves, usually stays taller than it is wide. And I think it was introduced from the Netherlands in the 70s. So there are some trees that I've seen that are quite large, and I think it will stay more restrained over time than our typical weeping beech, pendula, but it is a fan favorite for sure. And then if you walk through the woods in Mayantonomi Park, you will see dozens of not American beech, but European beech trees that have seeded into the woodland there. And we have not inventoried these trees, and they're in different stages of condition. Some are in decline, but it is, if you walk through the woodlands there, it's kind of reminiscent of a beech forest in Europe or in Germany or in England. So some notable beeches of Newport's past. So I believe these trees were in Scott's presentation. These are all at Aquidneck Park, and the Newport Arboretum has a wonderful legacy of housing noble beech trees that have been enjoyed by the community for generations. All 3 of these trees are gone now. The tree on the right, you can tell, is that classic ice cream scoop crown of the fernleaf beech. And that's, I believe, up by the playground at Aquidneck Park. And then on the left, you have a purple leaf form and the species form. And I believe one of these trees collapsed and the other two were removed about 15 years ago because they were in a state of decline. So it's important that we continue to curate and care for these trees so that we can carry on this legacy of having remarkable beech trees in the Newport Arboretum. So what are we doing to care for our public beech trees in the Newport Arboretum? Well, like Natasha said, we've got some new toys, or new-ish toys, I should say. A truck, a 250-gallon water tank, a trailer, great for moving around supplies. We've been able to hire a part-time position, which we call the field arborist, and that is the person who kind of leads the tree care in the public space. And we're very grateful for our trusty group of volunteers who do a lot of the work for us. So we've been able to do more specialized tree care. We have been able to weed around the bases of these trees, provide a nice thick layer of mulch to retain moisture and keep the weeds suppressed. And then we've been able to irrigate the trees we can with the irrigation tank during times of drought. And once we come in and we provide this mulch and this irrigation if possible, the city forestry team comes in and they have, the last 3 years now have, come on. There we go. Oh, all right, there we go. And they have performed the soil drench, the polyphosphite, a product called Companion Max 30, and that's done twice a year during the summer, and we've done that now since I believe 2021 or maybe 2022. So that's been able to keep the trees in a stable condition. We certainly haven't really seen much decline from the Newport Arboretum's beech collection, and this polyphosphite will provide reserves while the trees are struggling that are symptomatic with beech leaf disease. And of course, preservation for the next generation. It's been said before, I'm sure it'll be said again, but we want the recently planted beech trees to achieve noble sizes. And you can see this is the most recent beech tree we've planted in the Newport Arboretum. I believe that was a fernleaf beech planted in 2022. So we want that tree to achieve the trunk diameter of a massive noble beech specimen. And of course, the other day I went out and I looked at the emerging lime green leaves of a fernleaf beech near our office, and I just got so much joy from it. So I hope that that's something that people can enjoy for generations to come. So thank you very much, and I'll turn it over.
Good evening, everyone. My name is Jeff Curtis. I'm the Director of Gardens and Landscapes for the Preservation Society. Tonight, I just want to talk to you a little bit about what we've been doing for the past, say, 40 years. Jim Ingram, he's there shaking his head. Back in 1988, that was the year that we did our first inventory, our formal inventory of all our trees and all our properties for the Preservation Society. And Jim Ingram and a gentleman by the name of Bruce Frederick were the two that spearheaded that project. In fact, just 3 years ago, in the height of the beech leaf disease, we did a recent update of our inventories. We've done a number of different updates. This was about our fifth or sixth one. And it was perfect timing, everybody, because everything that was going on with beech leaf disease, the one thing that these inventories, these updates do for me is just it prioritizes the work that needs to be done. And with everything that was going on with beech leaf disease, that was our priority right there, because the future looked very bleak a few years ago. And all I've been doing for the past week is just going around up and down Bellevue Avenue looking at every beech tree as soon as they leaf out to see what condition they're in. And so far, my observations have been very good, very, very promising, But I tell you, it takes a load off you, because with the inventory, we categorize over 2,000 trees that we take care of now. Back in 1988, it was 1,800. So we've done a lot of work in the past close to 40 years with our tree inventory. Jim, I don't know how many more updates I have left in me. Maybe one or two, but I tell you, it's been a pleasure working with Bartlett doing these inventories, you know. This photograph, the first photograph you see, is a picture of the breakers, and it has the beech trees picked out on that landscape. I think at the breakers there's 23. Preservation Society has a total of about 260 beech trees on all our properties. This past winter, we've done a lot of work, a lot of pruning, some removals, but this is the first year since COVID that I've been able to get into my nurseries, both down my greenhouse, down behind the breaker stables, and out at Green Animals. We actually dug up 11 beech trees. And the problem I'm having now is, like during COVID, we did absolutely nothing when it came to planting. I mean, I was just busy out there trying to get the grass cut and rake the leaves. That was like on the back burner back then. But the trees didn't understand that. They were still growing. I mean, every single beech tree that I have in those nurseries, they're over 6-inch caliber now. You know, years ago when I used to do a lot of digging, a lot of transplanting with beech trees, and the size of the tree never really mattered to me. I was young, I was strong, I could do anything 30 years ago. But nowadays, you know, I recommend to everybody, I don't transplant any beech tree over, say, 3-4 inch caliber, because back then, you didn't have the problems you had nowadays with the beech. You know, back then it was Phytophthora, okay? And even back in the late 80s, early 90s, I was still able to transplant, do my thing, and you always had signs of Phytophthora, but it wasn't at the scale it is now. And I think a lot of that's got to do with just climate change. I mean, this climate in New England, it just goes from one extreme to another. The rain that we get, the heat, the cold, the fluctuation of temperatures is just, it's not like it was, say, 40 years ago, 40, 50 years ago. But there's nothing you can do about that. You can't change that, so you just have to deal with it. And the way you do your job, the way you manage your tree population, you have to make those changes. And one of the things that we've been doing, this picture right here, this is a fern leaf beech at Chepstow, one of my favorite trees. This thing was planted probably in the mid-1860s, right after the house was built. But the one thing that this picture shows to me is that the amount of mulching that we do with all our beech trees. What we do now, probably since the early 1990s, we save all our leaves, all our wood chips. We have a lot down the street right next to the elms where we're able to store all of our compost. And we compost all our leaves and wood chips. And let me tell you, 2,000 trees, that's a lot of leaves. For all you Newporters, I'm sure you know where that is. It's behind the old Lenthal School, right next to the elms. But every year, I generate probably close to 300 yards, 300 cubic yards of this. I call it leaf mold. It's basically just leaves and wood chips. Every once in a while, you might see a few grass clippings or some hedge clippings mixed in, but 99% of that pile is just leaves and wood chips. And ever since then, we've been using it. And this area right here is a perfect example. This tree, every time I mulch this tree, probably every 2-3 years, you're looking at probably a good 5, 6, 7 yards, cubic yards, just for that one tree. Never mind, we have a total of, what did I say, 260 beech trees? Not all of them are that size. You know, we have a lot of smaller trees that I've planted over the years. I think this winter, Jim, when I do my own inventory, I'm going to count how many trees I've planted. So next year I'll be able to give you that number. But I'm sure it's been over 100 trees, beech trees that I've planted, you know, since I first started here, you know. But the one thing I can recommend to everybody, and one thing I always say to everybody, if there's one thing that you can do to better, just to, you know, to make the tree survive the elements, to feel, I always say just to be happier, you can mulch your tree, because like I said, for years now, what I've always said to myself was that in order for a tree or any plant material, it doesn't have to be a tree, it could be any plant. If you want that plant to be able to survive the elements, survive any physical, any problems that are out there in the world with all this climate change, the only way you're going to, these plant materials, these trees are going to survive is just to keep them as healthy as you can, And then when this beech leaf disease comes about, sure, they're going to get it. All the beech trees are going to get it, but at least if it's healthy, it can fight off that problem a little bit better. And not just beech leaf disease, insect problems, aphids, whitefly, all those insects that are out there affecting the trees. Working in the greenhouse for a number of years, I managed quite a few greenhouses with my job, and the one thing I've noticed just by working in the greenhouse, how if the plants aren't healthy, if they're not doing well, these insects and diseases know this. They're going to come to those plants that aren't doing as well. Let me give you an example. I grow a lot of poinsettias during the Christmas season. I have over 2,000 poinsettias in one greenhouse, okay? And they're all laid out on the bench. Beth, I know you know what I'm going to say about this, but every day I walk down that foot walk, and if I see that one little poinsettia that's not doing as well as the others, all the others are doing fine, they're happy, they're growing, but this one little guy is just struggling. And sure enough, when I look at this plant, there's the whitefly. There's the aphids on them. Now, why are all those insects going to that one plant and not the others? Okay? So that tells me right there that it's not just the plants in the greenhouse, it's plants everywhere, inside, outside, okay? Greenhouses are their own little microclimate. It's not like being outside. Being outside is a lot different than managing plant material in a greenhouse. But all that knowledge that I've learned from working in the greenhouse, I've been able to take that and bring it outside and do the same thing with the beech trees, or like I said, or any plant that we're growing outside, So with that, I just wanted to thank everybody for coming, and what I'd like to do now is introduce Mr. Ingram, who is the president of Bartlett Tree.
Good evening, everyone. Yeah, good evening it is. Jeff is one of the best horticulturists in the world. I've worked with hundreds of horticulturists in all our operating areas and through 42 states, 3 countries. You're the best. Jeff listens, he learns, and he leads. He's unbelievable when it comes to managing these beautiful properties. And the mulches that he lays down from the resource, he's been able to stabilize the soil environment, create that moderate soil temperatures in the winter. Use beech as an example. Beeches have huge buds, right? And they actually desiccate in the winter. So if you can stabilize the soil and moderate soil temperature so it doesn't freeze, so when those winds off the ocean hit the beech canopies, they don't desiccate. They can actually still breathe during the winter. That's awesome. I think it's one reason why your survival's been so good, notwithstanding some of the insects and diseases that we have to contend with. But tonight I wanted to thank the Preservation Society of Newport County, Newport Conservancy, Quidnick Island Land Trust, Salvi Regina, and the City of Newport for organizing this evening. This is fantastic to actually get the education out there to the people that make it happen, and you all love trees or you wouldn't be here. It's really highlighting the iconic trees of Newport. Your talks are fantastic, really good. You're passionate, and that's what it takes. I'd also like to extend special thanks to Jeff Curtis, Jim Donahue, Scott Wheeler, Natasha Harrison. Joe, you did a good job. You look good, man.
You look good. And Terry Sullivan. With a very special thanks to Trudy Cox. She's not here, couldn't be here, but she really wanted to be here, and I'm sure she's out there in Cyberland somewhere. So, a wise man once told me, with trees we will live to be judged by what is left behind, not by what has been taken. Our trees are historical documents that faithfully record our personal philosophy. Let us tell a story of tolerance toward living things and of skill in the greatest of arts, how to properly understand the history, culture, concerns, and management, one species at a time. And that's what it boils down to. It goes beyond that these days. We have to know about the cultivars that have the tolerance to withstand some of these soil conditions and insects and disease. And we need to know the cultural tending. We need to know the pH tolerances for the soil. So these treatments that we administer, the tree can actually utilize them. So that's important. You're going to hear a lot about that tonight. The Bartlett Company recognizes that our scientists' ability to exercise innovative science in their research, guided by society's intent, is critical to success in managing tree cultures. Tonight, I'm really proud to have 3 of our 18 researchers here helping Newport at large, and actually the whole country, and actually Europe, and Canada. It's pretty cool, the research that has been done since 2018, when we started on this quest to learn what was going on with our beech culture. My background's forced genetics years ago, 40-some years ago. It used to take us like 20, 30, sometimes 40-year rotation to figure out what trees were tolerant to withstand some of these pestilence. Today, we can turn it, and we've got some brilliant minds with us. We've got Dr. Matt Borden, we've got Dr. Beth Brantley, and Dr. Andrew Lloyd, all plant pathologists, all educators, and they're going to educate us on the latest research and management tactics for beech species tonight. So we're going to start with Matt. Matt, you're up.
Thank you, Jim. That was great. Good evening. It's very nice to be back here again, and I just want to say it's such a joy to continue to have a role in preserving the beech and other trees in this town. It's always exciting for us to come back here, so thank you. I'm going to give you a recap and update on the management programs that we have been developing over the past several years, and then I'll be turning it over to Beth to sort of put it all together into a more holistic picture. So, first, let's discuss where this came from, where it's going, put it into perspective. This being beech leaf disease, started around 2012 in the Cleveland, Ohio area. And even for an invasive species, this level of spread that you see on the map is remarkable, especially when you consider that this is not some large beetle flying around like emerald ash borer. This is a microscopic nematode, a worm that on its own cannot move very far. And yet, since 2012, it has spread to 15 or 16 states now, a large part of Ontario, and it continues to move. So this is quite something. On the other hand, this gives us some good opportunities. This allows us to study this problem in a wide range of environments. So this map, the little highlighted icons on the map, show you where some of our research has taken place. These are just the trial sites that we've put out in order to learn more and develop the programs that we have now implemented here. So we study beech leaf disease in Ohio, where it has been for the longest, and that's a very different climate than studying it here in New England, where we have, for example, much more dense stands of beech. It's often much more severe. And then we study it as well on the leading edge of the beech leaf disease spread, so that we can see counties where maybe it's only been for a season or so. So, you take what you can get, and in this case, we are able to study this problem in a wide range of environments, which tells us a lot. I'm going to talk about our two management programs and try to break it down to just give you how it works and what is the point, what is the target, all of that. So the big point here is that these are two different programs that we have designed for different situations. These are different tools for different kinds of trees. So for example, the first program we call a foliar nematicide program. That means it is something that is applied as a foliar application directly to the canopy of the tree. This is really designed more for small to medium-sized beech, particularly because this is typically made by someone on the ground spraying the canopy. So coverage is extremely important with this program. It's also really good for dense plantings such as formal beech hedges or more formal symmetrical plantings where you have a lot of beech planted very dense and sheared. That's ideal for this kind of program. So how does this work? We use a particular chemistry that was one of several, what the literature refers to as a next generation nematicide. This was one of several groups of chemistries that was developed a few years back to help replace the old broad spectrum nematicides of the past that were phased out over the past several decades. So in comparison, this nematicide is much more selective, which is a good thing. We're not trying to kill everything in the soil like the old nematicides did. And it works by targeting a specific cellular respiration pathway in certain nematodes and fungi. So it's a good fungicide as well as a nematicide. This particular product is used in agriculture, primarily fruits and vegetables, tree fruits. It's also used in the nursery industry a little bit, turf, golf courses. However, we found this new use for it for beech leaf disease. And based on our initial research, we got this label that you see on the screen, which allows that particular product to be used on beech trees to control beech leaf disease. And this program is now in use in every state where beech leaf disease is actively being managed now. So how does it work? We have a very specific need of when we apply these programs. So we have to target this nematode, and this is really important, before it can get into the buds. As soon as these nematodes get into the buds, which they start to do periodically from about late summer through the fall, as soon as they get into the buds, they start to cause these cellular changes that causes the damage that you see the next year as beech leaf disease, the banding and all of that. We have to avoid that, which means that the point of this program is to target the nematodes while they are in the leaf and eliminate as many of them as possible before they have any opportunity to migrate their way into the buds. And the point there is to protect the next year's canopy. So this is a very unusual strategy compared with the way we typically manage a disease, where you might manage a fungal disease in the early spring, for example, or you might manage an aphid in early summer to avoid it having an outbreak later in the summer. This is a bit different. We target these nematodes to prevent them from getting into those buds that develop in late summer and fall. And these two trees that you see pictured here were right next to each other, by the way, in one of our programs. Top tree was untreated and bottom tree was treated. So very satisfying. This is what you see if you take apart some leaf tissue late in summer. And I put this up here because it's hard to believe that you can have this many nematodes, and this is about less than half a square inch of leaf tissue. Half a square inch. So when Andrew often talks about these trees producing billions, perhaps trillions of nematodes, this is why. If you have this many worms in half a square inch, you multiply that over one leaf and then multiply that over thousands and thousands of leaves on a tree, this is what we're dealing with. You know, it's not like having a couple of beetles on the canopy or something like that. Totally different ballgame. So we count these nematodes when we do this research. We look at the canopy before treatment and after treatment, of course, and look at the amount of disease, but we also take samples, take leaf tissue, bud tissue late in the season, count the nematodes, see how our treatments influenced those populations. We also take buds often in late winter or early spring before bud break occurs, and again look at the populations to see how many overwintered through the buds, because they will keep reproducing inside the buds over the winter. This is a fun example. So I flipped open the journal a few months back, and I saw that house, and I recognized those trees on the edge of the photo. I was like, wait a second, I've been there. This is Old Westbury on Long Island. These were trees that Mr. Bartlett provided some funding to put on our treatment program, and last summer, these trees looked fantastic. These trees are a little bit large for this foliar program typically, but they pulled it off. They did a good job. They got good coverage. And what was really striking here was if you turned around from where I took the photo and looked at the other half of this historic beech LA that was not treated, the rest of the trees down that entire row still looked pretty rough. So this program can be very effective. We prefer it for small to medium-sized trees. And we're always optimizing. So now that we've found this tool that works, we've got it labeled, now we move into a period where we are really trying to optimize when is the best time to apply. How many times do you have to apply it? And in particular, how much is absolutely necessary to apply? So I think I presented some preliminary info on this last year, but we wrapped up a really successful dosage study where we showed that we could manage this problem with a much, much lower dose than was previously believed. So this is the kind of work that we've moved into now. We're trying to figure out what is that exact best optimal timing so that we can manage this as effectively as possible, both from a cost perspective and also from an environmental perspective, because in general, for any kind of pest management, less intervention is better. And we've also done a lot of work trying to share this science. So we had this large peer-reviewed paper, both our studies and a lot of collaborator studies that we all published together. We've also put a lot of posters into scientific conferences, of course. We have our internal tech report that we write for our clients. And then there's been a lot of articles. So point here is that we've been bringing this science to whoever wants to see it. All of this is open access and free if you are curious. Happy to send you any of this, or you can find it online. All right, so that was the first program we call the foliar program. The next is this root flare injection treatment. This is a very different treatment, but the strategy is pretty much the same. This program is really designed for medium to large trees, especially trees that you can't really get good coverage on from a foliar application. So this is our preference for these historic large beech, such as what you have in this area in particular. It also has a lot of promise for managing beech leaf disease in forest stands, which Dr. Lloyd will talk about shortly. So how does this program work? There's fascinating history behind this chemistry. The active ingredient that we are incorporating here is one of the first of the newer generation of anti-parasitic medications that was developed in the early 60s. This was originally a veterinary medicine and also a human medicine to treat primarily gut parasites in herds of cattle, sheep, and all of that. The vet industry has since moved on to newer chemistries in the same class. However, the arboriculture industry, we're still stuck on this same classic active ingredient, and it's quite effective. If you've ever had Dutch elm disease treated on your property, this was probably the same product. This particular chemistry, thiabendazole, happens to be a very good fungicide for things like Dutch elm disease, but we have utilized it for its nematicidal properties going way back to its original history as an anthelmintic, anti-parasitic medication. So really neat history. I enjoy reading about this. What's important here is that this is a bit more specialized. This requires quite a bit of additional technical skill and training to make these applications successfully and do minimal harm to the tree. This involves drilling into the root flare, and the way you do that has a big influence in how the tree responds and seals over those small wounds in the long term. So this is effective, but it does require additional upfront training and technical knowledge to do this application correctly. And it's the same story. We've now moved into optimization. So we published this past year all of our initial field studies. However, now we are setting up new trials to figure out, okay, what is the optimal timing? Is it different if we apply this injection in June versus July? Is it different if we apply this dose versus that dose? So that's where we are at now. We'll be setting up a lot of new trials. And once we got this information published, we were able to get this treatment registered in all of the dark green states on this map. So almost every state where beech leaf disease is now active and being managed, all of those states have approved this product for use. Delaware is pending. But yes, it's been a mission to get this registered in all those states, and a lot of folks are glad that this is now out there. And this is other companies using this as well. So same deal, we've been sharing this science, making sure that other partners in our industry have access to the information. So the paper is published, we have a poster online, which I think there's some printouts here if you'd like to take a copy and read it to get a little bit more background of this treatment. And there's a lot of articles. It's good news, finally. You know, there was a period of time where this was completely doom and gloom. I'm sure many of you experienced that, so a lot of folks are glad that at least now we have some options coming onto the table. And with that, I'm going to ask Dr. Brantley to come up and put it all together into a more holistic perspective now. So Beth.
Well, thank you, Dr. Borden. You drilled it down. Now I bring it back out. And what a setting we have. Scott, Natasha, Joe, Jeff, Jim. Well, you've all already given my presentation. This is wonderful. Terry, shall I just hand it over to you now, my friend? This feels so good. I do have work to do. And let's zoom out and let's look at this from a much further away perspective. And in fact, think about our charismatic megafauna, our iconic beech trees of Newport. In this moment, while we wait, Natasha, for the green button to cooperate. Thank you for channeling me, my friend. This inventory that has been spoken of, these 300 plus beech trees within the inventory in the Preservation Society collections, 60% are in good condition. That feels good to me. Does it feel good to you? It's a really good feeling. I hope that at least 60% of us feel good. Do we? We think about these trees, our love for beech, and the characteristic that makes them so important to each of us. Perhaps it's the longevity. Perhaps it's the shade they provide. Perhaps it's that potential for them to regenerate underneath intense shade. Perhaps it's that shallow-rooted, amazingly architectural system of roots that we so enjoy. And yes, Matt Borden, we so like to inject, correct, on the big trees. Perhaps it's the large geographic distribution which enables us such incredible genetic and phenotypic variation within the populations, specifically of American and European beech. And perhaps it's just the amazing ways they reproduce, be it sexually through seed or asexually through root suckers coming up from the root system, or that amazing ability that beech and other trees, some of them also have, of layering, where those branches bend down under the force of gravity and they touch the earth and the adventitious roots are produced. And sure enough, there is a clone. It is like a slinky. It is like an octopus. It is amazing. We love our beech. Thank you, Natasha. Keep channeling me, my friend. A week ago, the entire state of Rhode Island was in this yellow category called abnormally dry. Does anyone follow the drought monitor? Every week, I wait for it with anticipation. I want to see what's happening. And if we were to look back, friends, back to autumn, back to October, what would we have seen? Was it dry? Did we have a dry autumn? Did we have a dry winter? We have had issues here, and the trees tell the story, do they not? We don't know necessarily, we don't remember. But right now, even with the rain that we had over the weekend, we are still, as of today, in this state of abnormally dry here in Rhode Island. We are not done with the challenges, Jeff. We are not done. And what a segue into soil moisture. Taking this holistic approach and thinking about other opportunities along with our beech leaf disease treatments. What tools do we have in our toolbox? We can aid with soil moisture. I encourage everyone to add a new tool to your toolbox. A soil tensiometer, an aerometer, a soil moisture meter, stationary, temporary, check the moisture levels in our soil. We can do better. We can provide the care that all of our trees need. Along with this, and it is a wonderful segue into the presentations that have come before me, thank you all for setting me up, because indeed, mulch makes a difference. In fact, those of you who are able, will you please stand now? Thank you. I would like to say it. I would like for everyone to visualize your favorite beech tree. Visualize. I would like for you to repeat after me. Mulch makes a difference. Mulch makes a difference. Thank you. You may be seated. There is a culture of mulch believers among us, is there not? We are here, we provide testimony, we are witnesses, and we love mulch. Mulch provides that insulating blanket. It retains soil moisture. It reduces that thermal stress and the cold stress. But most of all for me, why mulch matters, and Jeff, I'm so thankful that you presented what you did with your combination of that composted leaf mold, along with wood chips, and perhaps a few grass clippings thrown in a bit, right? Like our own home composting. But think about this. It's the process of decomposition in that root system of our beech trees with the application of mulch. The organisms, the microorganisms, can take advantage of that and pull organic matter into our soils, into that profile, along with nutrients. Leading right into soil nutrition, we have the tools, take a soil sample, have it analyzed, and provide our beech trees and all of our trees with that with which they are deficient in. We have the tools. We also have the ability to address many of the problems that have already been mentioned. The aphids, the Phytophthora bleeding canker in this case, Jeff. We also have Phytophthora root rot, the mites. These are tools in our toolbox in a holistic approach to beech management. Take advantage of the opportunities to pull away soil that is up against the trunk of our beech trees. Expose the root flare. Find what's hiding under there. Eliminate those girdling roots. Think as well about the impacts of too much mulch. Pull it away. Free the trunk. Avoid the volcanoes. We can do better. At the same time, it is possible to love a tree too much, is it not? And as we all stand and enjoy at the base of our tree, and even our little feet make a difference in soil compaction. Let's take care of our tree roots. Let's do this. Let's not pave over them, please. And let us perhaps encourage exclusion from underneath the tree and let the roots thrive. I think not only about the compactionist damage, but I think about that love that perhaps gets carved into trees, that damage, that vandalism. Those people, yes, we're all in the room. We can have a session afterwards and admit guilt and be absolved. But I think about damage that may be inadvertent. Perhaps it's the exposed roots. Perhaps it's the roots in the turf that goes up to the base of the trees and those roots suffer every time the mower goes over them. Or perhaps it's just that exposure to the harsh conditions. It's time for mulch, my friends. It is with dignity that we hope we all leave this planet, correct? And perhaps we might extend that to trees in decline. Some decline is irreversible. And let these trees leave our landscapes with dignity and encourage that succession plan. All of these new trees, Natasha, Joe, Scott, it's so exciting to think about, is it not? It's the future of our forest. There are many additional considerations when we take this holistic approach to beech management and to the management of all trees. There are many players here, Jeff, as you alluded to. It's not just simple anymore, is it? There is so much. And these are the biotic players on our landscapes, those which we must look for, and we must assess accordingly. Perhaps not all trees are appropriate for beech leaf disease treatments. We take all of these into consideration in our holistic approach to beech leaf disease treatments as well as to beech management. We put them all together and we make a choice to treat or not to treat. And in doing so, taking this holistic approach to beech management, stepping back away, reading the landscape, taking into account everything that we see, and making these decisions. Are we keeping our trees as healthy as they can be? Are we making good choices about vigor? Are we providing the proper cultural care? Are we, in fact, using other tools, Joe, in our toolbox? The potassium, polyphosphonates, they're here for us. Let's use them to improve resistance within our trees. And after beech leaf disease is present on our landscapes, let's evaluate and let's use these tools that Dr. Borden presented us with, foliar applications and injections of nematicides, products with nematicidal properties. I thank all of you for your time and your engagement and your passion for beech trees. Thank you. I don't get to introduce you, Terry, but it's good to see you.
Yeah, nice to see you too. I was sitting there, and I was thinking, oh man, I have a fairly flat delivery when I speak, and I always have to follow people like you, Beth. It's just not fair. So I'm Terry Sullivan. I'm the executive director of the Aquidneck Island Land Trust. Since 1993, we've worked to protect the farms, forests, open space, watersheds that make this island so special. And before I get started, I just want to thank the Preservation Society. This is an incredible event, and they've just been such an incredible partner for our organization for a long time. I also just want to recognize Jim Donahue, who really organized all of these speakers today. So can we give Jim he's the organizer behind this. And we're working with Jim, by the way, on another partnership to build a rain garden out at the parking lot at the Marble House to capture stormwater off of the parking lot. So maybe we can do a talk about that after it's all done. So there are nearly 400 people, I think maybe even over 400 people signed up for this lecture, which is incredible. It's not normal. I've worked in conservation a long time, and to have 400 people sign up to talk about and learn about trees is just extraordinary. And I'm fairly new in this role. I've been in the role about a year and a half. What I've learned about Newport is it is packed with tree lovers. It probably has per capita more tree lovers than any other city in the country. So congratulations to all of you, and thank you so much for coming out. I'm going to unfortunately have to turn the tide a little bit because we've heard a lot of good news, but there is also an ecological disaster happening in our beech forests around the Northeast. And so we're going to talk a little bit about that. And it's happening right here on Aquidneck Island. While the specimen European beech trees of Aquidneck Island are what bring many to the lecture tonight, equally concerning is the impact of beech leaf disease on our magnificent American beech forests, our only native beech across the region. American beech are magical with their tall, magnificent canopies and their seedlings' ability to grow in the shade of the tree. The beech nuts are essential for wildlife, and unfortunately, you've seen a lot of good ideas for treatments of individual trees. We can't do that in a forest. There's just too many trees, so we cannot apply or solve this issue by treating each and every tree. Let's see if this works for me. Natasha? Great. The Land Trust owns a 20-acre old-growth American beech forest right here on Aquidneck Island in Portsmouth. It's called the Oakland Forest. It's a special place that we worked with the community to conserve 25 years ago. If it hadn't been conserved, it would now be condos. If you've never been, I invite you to visit. The preserve is open to the public, and it features a beautiful trail through the forest and around a meadow that is bright with flowers all summer long. Trees here are as old as 300 years. It's a quiet place of solitude for many, and wildlife abounds. Unfortunately, beech leaf disease has been decimating the dominant American beech in this forest over the last few years. So you can see the forest is changing dramatically. If you look at the slide on I think it's on your left, light now is reaching the forest floor as the beech canopy is lost. If we do nothing, invasive species will begin to proliferate. They already are in the canopy gaps. A few years ago, Oakland Forest was a place you could walk through in the middle of summer and feel a significant drop in temperature under the shade of the beech. Unfortunately, that is no longer the case with the beech leaf disease in the forest. The forest is changing. Seeing the change at Oakland has been heartbreaking, but we have a management plan for the future of the forest with three main components that I want to tell you about. First, we hope to protect the healthy secondary forest species already there. These include red oaks and white oaks, red maples, yellow birch, black gum, and other species. Second, we plan to manage the invasive species springing up in the canopy gaps, which is really no small task. And third, we have begun planting native seedlings, primarily oak, in the forest, and we have to wrap those with deer enclosures until they get big enough. The species that we have selected to plant in the open areas now are native to our ecoregion and already exist in the forest. And then finally, and why I'm here, we're also excited to be partnering with Bartlett on a study that Dr. Andrew Lloyd will speak about at Oakland Forest and other sites around the region. Our hope is our very own Oakland Forest will contribute to a national understanding of how best to combat this disease in nature, while also saving some of the keystone beech trees within the forest. If you'd like to learn more about the study, we've worked with partners to set up a story map, and you can see the QR code. Is it there? Yes. You can see the QR code on the screen. If you take out your phones and you point your camera at that QR code, you'll find a story map. We'll also put the QR code on our website. You can find it there. And of course, as a nonprofit, I'd be remiss to say we would certainly welcome your financial support for our efforts to protect and steward the forests and farmlands here on the island. They really do define the character of this wonderful place. So now it's my pleasure to hand over the microphone to Dr. Andrew Lloyd. He's a plant pathologist at Bartlett Tree Experts. Andrew is leading the research on evaluating beech leaf disease treatments in forest settings, including at Oakland Forest. Thank you.
Thank you, Terry. Thank you, everyone. I'm back again at the most fancy place I've ever given a talk. I've given talks in dungeons and basements, and this place takes it up a notch. So thanks for having us. Thanks for all the partners. Obviously, I think that's how the thing started was, hey, we can get good minds together, people who care about trees and nature, and we can make a difference. And I'd be remiss to say, also thank you to the company we work for, Bartlett Tree Experts, and Mr. Bartlett continuing the mission that his grandfather started with really prioritizing research. So we're fortunate to get to play around with trees and torture them and learn about all the critters that get after them. So my talk is titled Investigating Social Distancing. I think we know a little bit about that over the last several years. And herd immunity, you might have heard about that one too. And management tactics for beech leaf disease in forests. So how does this disease work? So Matt gave a good overview last year just to refresh your memory of how I think about the disease. This kind of came to me. I've got young children, and I was reading them, The Giving Tree, as one does. And I started to think about beech leaf disease in terms of this because my mind just goes in a bunch of rabbit holes all the time. So how's this thing work? So we thought, and we now kind of know, I'll go over that this disease seems to be very similar to this, where, the young boy was taking from the tree, and as he grew into a man, taking apples and finally taking the wood and utilizing it all. But he took too much, and he didn't give back, and he was left with a stump. And this nematode is doing something very, very similar, we think. So if we all remember dairy commercials, this is your beech on beech leaf disease. So on the left there is a healthy cross-section where the top of the leaf is the cuticle and the bottom is the underside. Normal mesophyll cells, you can see a vein in there, the circular part. And then the not-so-healthy leaf is one that's infested with this nematode. And you can see the mesophyll cells are all in disarray, and it's not going to be photosynthesizing very effectively. So some good research has come out. Again, I think thanks to all of the researchers in the beech leaf disease research community that have really set the stage to learn about the biology and the etiology of this disease. So this was from a U.S. Forest Service pathologist and physiologist, Cameron McIntyre, and he was able to show that through measurements that photosynthesis is significantly reduced. So these leaves are not photosynthesizing when they're infected with the nematode. And he classified them as banded, so that's a maybe moderate symptom, and then this crinkled leaf. These leaves will get real leathery and look really malformed, and it's really reduced. Stomatal conductance is also negatively affected. They're just stomata are open, which means that water can leave the leaf tissue more readily in the crinkled leaves. And then finally, they're not using water in a way that is efficient when you have the disease. Another great researcher who's really taught us a lot about the cellular biology of this nematode pathosystem, Paulo Vieira and others, were able to show these really beautiful micrographs here. Again, on the left, we're looking at a healthy leaf. And there's probably about 6 to 7 layers of these mesophyll cells in the leaf. So that's, beech leaves are very thin. This is like under really high magnification, you can get to this level. But on the right is a symptomatic leaf, and if you cut through a cross-section of that, you actually have more cells. You can have anywhere from 12 to 20 cells. So this nematode is tricking the plant into forming more tissue. And not only that, these cells are much larger. So the plant has to provide energy to make these larger cells and more of them. So we also know, and you've probably all seen this if you've been looking, that when trees have aborted buds, which can be a severe symptom of a large amount of inoculum or these nematodes getting into buds, they won't leaf out, it can allow for more light penetration in that canopy, and you'll get these secondary flushes of leaves from latent buds or axillary buds, and this also comes at a cost, and it's expensive for the plant to make them. A few years ago, we put together a study looking at the effects of the symbionts, the fungal symbionts, the ectomycorrhizae fungi, across a gradient of beech leaf disease. And what we were able to find, this was with folks at the Holden Arboretum and a graduate student at Case Western, Claudia. We were able to find that healthy trees, the one in the middle, good, had much more roots that were colonized and had root tips that were ectomycorrhizal. So this is a symbiosis between a fungus and a plant root. Whereas the bad, the very severe symptom of disease, had significantly less of these fine root tips colonized by this fungus. Okay? So they ran away just like Monty Python from the rabbit that was going to eat them. So then it brings me back to this story of the giving tree, and is this idea that this nematode starves the plant of its carbohydrates. So we partnered with the Forest Service, University of New Hampshire, and the Forest Service of Maine. We had 3 different sites in Maine. One was naive, the disease had never been present, high density beech forest. We had a low severity site, it had been there for a couple years, and then a high severity site where it had been there for more than 3. We collected root tissue, trunk tissue, and twig tissue. And I got to tell you, it was the first time I was able to collect twig tissue from these trees with a shotgun, which was pretty exciting. So our question was, is carbohydrates, are they actually being depleted when the trees have beech leaf disease? And what we're able to show is that all tissue types, branch, roots, and trunk tissue, when the disease was there at the low site, the high severity site, were significantly reduced in non-structural carbohydrates. Again, these are the storage carbon that can produce carbon and secondary leaves and all these things when the tree goes through a stress event. So beech leaf disease is affecting photosynthesis, but really how it's killing trees and making them go into decline is by starving it. So it's robbing Peter, but not paying Paul. So to summarize kind of how this disease works and how this is setting the stage of this forest management project, a healthy leaf obviously photosynthesizes normally, produces a flush of leaves a season, stores carbon, produces normal cells, has these beneficial symbiotic fungi that partner with it, and it's this balanced source-sink relationship. Where an infected tree will produce leaves that don't photosynthesize or function well, which is a cost. It can send out secondary flushes, which again goes back into the savings account, of the tree to produce these leaves. Produces more cells and they're large. It loses some of the partners that benefit together, and it disrupts this source-sink relationship. So switching gears from the individual tree and how this disease works, what about in the forest setting? What have we learned by looking at this thing for many years now? So one thing that I think is super important is that one observation we've made is that beech forests, natural settings here, American beech, the disease progresses faster the more dense that forest is with beech. So dominated beech forests, they have disease symptoms that come in faster, and they have thinning canopies much quicker than a low-density, highly diverse forest, which we know from other systems and things. This isn't super new thought, but it is what we're observing. Another thing that we're seeing, this is hot off the press, a paper that just came out at the Holden Arboretum in Ohio. They've been studying some trees for several years before and after the disease had been in this forest. And they looked at mortality, so what trees are dying. I think that's important. And you can see in this area, it was a pretty highly diverse forest. So they had maples, hickories, among beech and oaks. You can see it progressed pretty slowly as terms of mortality. And then what you can also see, if you get your eyes to 2023, you can see the darker area of that square or rectangle. It's really going towards the smaller size class trees. So the trees that are dying first are the smaller trees. Doesn't mean the larger trees aren't being affected, but bringing it back to carbohydrate depletion, a smaller tree is not going to be able to store as many of these carbs. So this makes sense. They're also seeing that on the left, the bar graph is trees and the change in DBH since they've been monitoring before the disease got severe versus on the right when it's tended to get a much higher incidence, meaning more than 70–80% of the trees had the disease now. And what you can see is that this disease is slowing down the radial growth and the formation of wood in these trees. Once the disease got severe, it significantly reduced the change in growth. And then it's also important, I mean, Matt showed that great video. It's one that haunts our dreams because we count tons of these nematodes a lot. We've seen them. We kind of consider them friends because we're weirdos. But here's our friend with its eggs. This nematode can blow up in population super fast. So if you think about these trees as nematode manufacturing plants, that's essentially what they are in a forest setting. And then we've also noticed that this disease seems to produce first symptoms in an individual tree at the bottom part of the canopy, but in a forest, the understory is affected first, then the midstory, then you find it in the upper story canopy. And there's some important reasons here. If you think about the lower part of an individual tree or the bottom floor of a forest, it's much more humid down there. There's more moisture close to the soil, and there's much more shade. So if things are vectoring this that have wings like birds, there's much more refuge in the canopy, below the canopy. They can hide from hawks and other things. But also the environmental conditions are more conducive for this nematode, which requires moisture to move from leaf to bud. So now we're considering management scale. Matt did a great job kind of summarizing our updates on treating individual trees. But we started to ask the question, really when we went to a client's property that we had done a trial on, and this poor guy had basically all beech. I mean, there was no diversity here. Beech leaf disease was super bad. He told us, he said, you got to think outside the box. So we started to, I mean, we thought in a particular box. We didn't think super far outside the box. But we wanted to look at some silvicultural practices that may play a role in this disease, like they have for so many other systems like hemlock woolly adelgid and spongy moth outbreaks. So what we know about this is in crop tree management or forestry production, people that are growing trees for timber, they do periodic thinnings of their stands. And what this does is they get an early payout on the timber that they harvest, but it also increases the growth rates of the trees that that remain on site, which is big for someone that's growing a crop for economic value. But can we take this and put it into a natural system to help our beech that are being starved of carbohydrates? Think about growth rates here that means it's going to form more wood, and that wood's going to be able to store more carbon, hopefully making that tree more resilient. So that was a drawing. Here is a picture of a core of a white oak tree that was part of a thin. That red arrow points to when the thinning occurred, and you can see the growth rate difference is drastic. Okay, so we do know the root flare injections is seemingly effective when done appropriately. And so if we put all this together, we come to this idea of this project where we're going to investigate social distancing and herd immunity management tactics. And again, this is a partnership and collaboration with the Aquidneck Land Trust. Thanks to Alex and Sean and Terry for working with us there, as well as the Pennypack Ecological Land Trust, which is down near Philadelphia in Pennsylvania. And we're working with Rainbow Ecosciences, and then we're also working with a professor, and one of our employees is going to go work with her in graduate school at Virginia Tech. So social distancing and herd immunity, oh my goodness, do we really need to hear about this stuff again? Yeah, we will. We'll get through it together. So our major questions is, if we can slow beech leaf disease by removing some of these nematode manufacturing plants, so we can reduce the inoculum, and then we can also do some crown separation pruning to allow light gaps to come in the forest, can we slow it down? And further, maybe we can't treat every single tree in the forest. Maybe we can treat some of them and strategically place them in a forest to where we can contribute to a lower level of inoculum, and maybe these treatments can actually protect their neighbors that aren't treated, much like immunizations. And then what about a combination of selective removals and crown release, pruning, and treatments? So we know social distancing. I think this idea does many things. Removes the nematodes from the forest physically. It increases the air and light flow, which will make the environment less conducive, in theory, to this nematode moving and causing infection. And it should also make some of the crop trees that we keep a little more robust in their growth and storing more carbon. Whereas this herd immunity, on the left, nobody's vaccinated, so everyone gets infected. Hopefully, we're all good here, right? All right. But when people have vaccinations at a certain level, you can start to protect the community when there's people that can't get vaccinated for health reasons or whatever. So can the same theory apply in beech trees? So what are we going to do? So our two sites, the oak forest over at Aquidneck Land Trust and Pennypack, both of these forests, we picked areas of the forest that are highly dense in beech. So more than 70% of the trees are beech trees. In Aquidneck, it's actually closer to 90. There's some other differences between these two sites. The Pennypack site, the disease was first detected last year. So this is a new wave of the disease coming through. And actually, those nematodes in that video came from buds from that site. The Aquidneck Land Trust, the disease has been there for much longer, so the symptoms are a little more severe, but also very highly dense beech. So here's an idea of what these forests look like. Here's Pennypack. You can see like 9 out of 10 trees in this photo are beech trees. And here's Aquidneck, a section of it. Again, a lot of beech trees. So at these two locations, we basically are setting up 2 different blocks for our treatments. And within each block, we'll have 4 quarter-acre plots. And these 4 quarter-acre plots will be randomized to different treatments. So we'll do the selective removals, crown release, pruning. We'll do root flare injections on 50% of the trees, a combination of the two or nothing. And then we will monitor these over a 5-year period. So here's a schematic, again, showing you these different treatments. So what we've done so far, this is the timeline of things. We've done our initial inventory and looked at the trees. I'll give you some stats on that. We're going to wait till they leaf out fully to assess the disease, to figure out which ones we're going to keep in our pruning trials and removal trials. And then we'll start the hard work of getting in there with chainsaws and cutting trees down and do the root flare injections. But what I want to point out is everything is happening before this dispersal period, these nematodes moving from the leaf to the bud. So it's possible that we can see an effect of these treatments as soon as next year, if we're lucky. But we will monitor it for 5 years. So what do we find at the sites? At both sites, when we include all of the 8 treatment plots at each site, we have about, right around 400 trees at Aquidneck and about 300 at Pennypack. And you can see that, again, most of them are beech, being the gray bars here. The other species, you can't read that, I don't expect you to, but it's some of the ones that Terry mentioned. There's black gum, red maple, white oak. There is actually the most impressive tree at the Aquidneck site was a very large 30-inch sassafras. That was quite nice. So what are we going to measure? We'll measure disease progress by looking at the canopy and visually assessing the amount of beech leaf disease, as well as fine twig dieback or canopy transparency. And hypothetically here, this is what we kind of expect. This is our hypothesis, right? That our thinned only treatment and our injection treatment, it'll last as long as the effect lasts, and it might not be the entire 5-year period. So managing a forest actually does take some time and thoughtfulness, so you don't get back to square one. But we do think we're going to get this added longevity when we manage it with an integrated approach using our treatment program as well as the silvicultural practice. Another way we're going to measure this is by taking canopy photographs in key spots over time in the same location and look at the amount of light we can see. Obviously, we want to see a change in that for the better in our treatment plots, so it would go from something like the top left to the top bottom if treatments go well. And then we'll also utilize drone technology to fly these sites and look at some vegetative index ratings as well as potentially using something like LiDAR. The other thing we're going to do, we might as well this is a very large investment, and it's going to take a lot of work. We might as well utilize it to study other things. So we want to look at what's going to come in. If we open up these light gaps in the forest, what are the woody plant species that are going to come back in their place naturally? So we've designated some areas that are about 100 square feet in each of the treatment plots, 4 of them each, and we're just going to calculate them once a year of what's there. And then we're also going to do some ex situ planting. So it's good to see you guys are already planting. I think that's great, and I think that is a part of a management tactic that is necessary to have a resilient forest. But we're going to look at probably 6, maybe up to 8 species that are, again, appropriate for the ecosystem, and see how they survive as well as grow under these different conditions of our treatment plots, with the idea that forest managements and large landowners are going to want to know what trees do best, and then how fast do they grow to outcompete maybe the weeds that we don't want. But I will say the best definition of a weed I ever heard was a plant whose virtues have not been understood. So the bottom line of all this, it's right there, it's green, is that we want to look at long-term sustainable management solutions to preserve American beech as well as our forests, and reduce the overall impacts of this impressive but devastating disease. So I'd be remiss if I didn't acknowledge our research crew. Sometimes it did feel like we were looking for that holy grail, but we're hoping to learn more, and we can only do this through partnerships, people letting us play with their trees, so we really appreciate that. And thanks again, and there's my email if you have questions. Appreciate your time.
All right, so that was an hour and 45 minutes, but I have to say it flew by. It was so interesting and varied. We do have a couple minutes for questions. Our goal is to get you out onto the terrace to have a nice drink on this evening by 8 p.m. So I'm going to run around with my microphone like Phil Donahue. And I'd ask that our presenters come up to the podium to answer the question so that the people on Zoom can actually gain the answer. So I'll come right down to you.
Whoever would like to answer this question. I have a concern as to how the trees are connecting with our entire environment on the island. So, Almy Pond, the dirtiest pond in probably Rhode Island, is affected by what we do. I see a lot of gardeners out everywhere in this neighborhood just mowing and blowing. I'm happy to hear the Preservation Society is saving its trimmings and reusing them. But I worry about all the nice green lawns where we have no flowers, no insects, no bees, and I think that this must be affecting our trees as well.
Anyone want to address that? Okay.
So we did address this a little bit in looking at our canopy cover. I mean, one of the things that I first learned from plant pathology from Dr. Tatter at UMass was that trees grow in the forest. And so anytime we're mixing grass ecosystems with forests, it's a very unnatural state. So all of this emphasis on mulch, what we're really doing is returning the forest leaf duff. If you can just leave the leaves to begin with, that's all the better. So we really want to, as we're looking at our environmental systems, be it trees, meadows, grasses, restore some of the natural functions. Plants can be beautiful, but they also can provide a lot of environmental benefits. And I think, Terry, might want to talk a little bit about your effort with Paige Myatt.
Yeah, thank you. I just wanted to mention also, to build on what Scott said, it's important that we begin to, in highly developed watersheds like the Almy Pond watershed, that we do more to capture stormwater on our own properties. And this is why I'm so excited about the rain garden project we're doing here at the Marble House. We also, and that's a really big rain garden. It's very engineered and so on. But we also just this week put a small rain garden at our Spruce Acres Preserve that demonstrates how homeowners could do this on their own properties. The purpose of rain gardens is it introduces more plant variety, as you said is needed, absolutely the case. But it also just stores and holds that water in place and allows it to be absorbed into the ground and for the plants to uptake the nutrients that are really damaging and causing the algal blooms in Almy Pond. So more to say on that. We're going to push an effort to see if we can encourage more rain gardens in these highly developed watersheds we have on the island.
Okay, we have a question over here.
One really very practical question. Where did these nematodes come from, to start with? Are there any beaches that are resistant to infestation by the nematodes? And is there any chance of eradicating them completely? Because if they came in, can they go out just as quickly in some way?
Yep, thank you for the question. It is a good one. I don't know that Donald Trump will get rid of these nematodes. That's a bad joke. So this nematode, for a long time was speculative that it was an invasive introduced species, and I think we're pretty certain now through the work of people at the USDA and the Forest Service through some genetics work that it probably is. I mean, we're still not 100%, but in the upper 90s, I would say, and likely from Japan. So it fits the invasive species introduced type species hypothesis where our native beech as well as our European beech are super susceptible. They haven't evolved with this nematode, so they have no innate defenses against it. These folks, led by Bob Mara from Connecticut Experiment Station, went to Japan last fall, and they collected nematodes as well as looked at Japanese beech, Fagus crenata, and some Fagus japonica in mostly the northern part of Japan. And they were able to show that these trees actually had what we would consider a hypersensitive response. So it was hard to find leaves with the banding patterns in the trees, but when you look down, there were a lot of these leaves in the mid of the growing season that had symptoms that had fallen off. And wouldn't that be nice if our beech did the same thing? But they don't, because they don't know how to respond. So they're continuing that work, looking at the genetic structure of the populations in Japan and compare it to the US. Likely there's going to be a higher level of diversity in Japan compared to here, meaning that it was one or maybe a couple introductions in this country. As far as resistant or tolerant species, as I alluded to there, Japanese beech, Fagus crenata, and probably Fagus japonica do have this tolerance to it. They can still get infected, but they can deal with it quite well. And we were just at the Arnold yesterday, I guess it was, and we might be there tomorrow, though it looks like a lot of rain. But they have some Fagus crenata, they have some Fagus japonica and lucidus that are completely fine. So these Southeastern Asian varieties and species seem to be somewhat tolerant. So, we live in a global economy now. I think we should expect more of these things to be introduced into this country. This is somewhat normal. And so this idea of what does nature look like is a philosophical question that we all have to battle. And does it mean that we should be starting breeding programs, which some people are in the Forest Service and the Holden Arboretum, and should we be backcrossing with some of these Fagus crenata into our American beech, or planting our urban landscapes with these tolerant species that have less issues, which would mean that the nursery trade would have to start propagating them, which is a large task. So, is that good? Eradication, we can all cross our fingers and pray to the nematode gods that some biological control comes in and gets rid of it. But, with these invasives, it doesn't have a lot of good things going for it, but we can hope. We would all like that.
Hi, I was struck by your comment and you showed that apparently the nematodes came or started like somewhere in Ohio, I think it was, and then how you hadn't figured out how fast or why it's moving so fast up here to the northeast. And I wonder if you can comment, have any thoughts? You just said you were struck by, you hadn't figured it out, but what are likely sources for that?
Matt, you
Likely
talked about
reasons
this.
for
You
that?
want
And then one other, maybe Matt's a good question, fellow, for this also. There's the big threat of antibacterial resistance by treating with antibiotics. Is there any threat that the nematodes might develop a resistance to the programs that you've already identified?
Sure. So for the first question regarding its spread, we have no idea, quite honestly, how or why it ended up in the Cleveland area. Andrew and I have our pet theory, which is that possibly someone imported some bonsai, because Japanese beech species are used in the bonsai trade. And if they imported some live material that had the nematodes in it but wasn't particularly symptomatic, people put bonsai in their backyards for the season. Maybe but that's our pet theory. We have absolutely no proof of that. It's the only thing we've been able to figure out of how live material may have made its way here, because these nematodes will die rapidly if they are completely desiccated and don't have a host. As far as spreading, it's primarily prevailing winds. It's probably a lot of wind-driven weather patterns of why it is spread east and north much, much more effectively than it has spread south and west. It is moving in those directions a little bit, but at a far slower pace. It hasn't even gotten to Columbus, Ohio yet. It's made its way all the way to Maine before it's gotten to Columbus, Ohio from Cleveland.
What would be windborne? I can't imagine the worm itself being windborne.
The worms themselves can easily be windborne. They are small enough that they can move in a light breeze with good humidity. Yes, that's pretty well established now. They can move from one tree a couple hundred feet down to the next tree just on a good stiff breeze. Now, there are other theories that perhaps birds have carried them as well. We know that they can probably get picked up in a droplet of water stuck on a lot of different creatures. These organisms are so small that they will stick if something is moist, much like fungal spores might stick and be spread around the landscape as well in some cases. So there's probably a combination of different methods of how it is spread. But in terms of this huge momentum in one direction, most likely has to do with weather patterns and prevailing winds, spreading it through the forest in that area. Now, your second question regarding resistance, that is absolutely a concern. We haven't met a pest yet that will never become resistant to something you throw at it. Same is true for nematodes, and especially parasites. In particular, we've learned a lot about resistance to nematicides from the veterinary industry, where same as with human medicine, with human antibiotics, you have a tool, it works great. If you overuse it and you treat everything and you start treating populations that don't necessarily need to be treated, you develop resistance. So in this case, there's a couple of things going for us, actually. The genetics of this particular nematode are quite narrow because it's probably a single introduction from Japan or maybe a couple of introductions, but its genetics seem to be much more narrow than its native population. It also tends to reproduce almost exclusively parthenogenetically once it's inside the buds. Sexual reproduction is where you get a lot of genetic crossing and potential for mutations that lead to resistance. So we're also not treating every single tree. If you treat a beech tree on the landscape, you probably have, I don't know how many times more nematodes surrounding it in your surrounding environment or woodlands that we're not treating. If we were treating from like an airplane and crop dusting an entire forest patch constantly, we would get resistance much more rapidly, I'd expect. But yes, to answer your question, it's absolutely a concern. We have not seen any resistance yet. We don't expect that to happen anytime soon, but we need to make conscientious use of the tools that we have not to overdo it to delay resistance as long as possible, same as we've done for many other pests in the past. Thank you.
I have a question. Perhaps, I don't know who should answer it, but first of all, I just want to say it's just so thrilling to see everybody here who really cares and worries about their trees. And then to know that we have the Tree Conservancy, the city, the Preservation Society, the Land Trust, and then we have specialists. I mean, we're all worried about this illness, and then we have specialists like Bartlett Tree. It's just, I feel so lucky, and thank you all for participating, and all of you. Now to my question. I don't understand that if you have the beech leaf disease and you're putting all your leaf and your cuttings and so forth into your mulch, and you've got maybe this is for you. Why, if you then go around and you put all these, detritus from the trees in your mulch, and then a little bit later you take the mulch and you put it underneath your healthy trees, why aren't you spreading the nematodes from your mulch on back onto your trees? So.
Sure. We can do it together. We can all do it. Yeah. So come on, Andrew. Let's do this.
Beth party.
Here we are. Great question. Let's start with when the leaves fall in autumn. Leaves have fallen, but the nematodes have already migrated. They've already gone to the hotel. They've already gone to the bud. They're there. So now we have these leaves, and correct me if I'm wrong, but the majority of the nematode population has already left the leaf. So the leaves fall, and in the process of decomposition, and this idea of mulch, where we're having microorganisms, bacteria, fungi, insects, other arthropods, breaking down that leaf material. This is why we are not seeing perhaps a source of inoculum represented in the mulch. Dr. Lloyd.
Yeah. So there are quite a few nematodes left in those leaves that have fallen. The fortunate thing is that they're mostly males, and these males are not really important to this pathosystem. I often say to my wife that I feel like the insects and the pathogens, they might have had it right, in their society structure. But yeah, the males are not really that important because they don't really outcross, and the females are what are causing the bulk of the damage in these buds. The leaves will break down super fast. They're very thin leaves. We're not advocating for putting infested leaves or on underneath healthy trees, just in case. I mean, there's obviously possibility that there could be females or juveniles that can be moved through critters or whatever. I would say if you're thinking about for the project where we're working on at the land conservation sites, where we're going to be doing these removals, we're going to leave all the debris on site for wildlife habitat, for decomposition. And the other thing we need to keep in mind is that this nematode only lives in the leaves and the buds. Doesn't live in the twigs, doesn't live in the wood. So the bulk of that mulch being composed of wood, it really doesn't have this nematode. So that's a good thing. And if you're composting correctly and it heats up, these nematodes are going to die rapidly. So just got to be smart about it.
Thanks, tag team. May I add one more thing?
Please.
And the other thing I would add is a tool that we have in plant pathology is indeed sanitation. When we think about fungal leaf spots, for example, it's so important to rake those leaves away. For example, I think of sugar maples, and the leaf spot fungi will stay dormant within spore structures in those leaves.
All right, well, I'd like to thank all of our speakers. It's 8:04, so thank to all of you this evening. It's been an excellent, informative evening. I'd like to thank all of our Zoom participants. Unfortunately, you can't join us on the terrace for a drink, but just think about it. and thank you all.